Okay, good evening, students. We are going to discuss today our practice paper 6. Okay, so this paper contains again 10 MCQs. So let's see what are the questions we are going to discuss today. Questions from atomic structure, from the recent topic we discussed, the first 2 MCQs. Then we are having nuclear reaction MCQ, and then 2 chemical calculation MCQs. Then we have some theory MCQs, which are coming from first unit. Okay, right. So let's start from the first one. So this first question is from the theory that we learned in our last class. There in our last class, we discussed the types of electromagnetic radiations, and then about the energy transferring that happens in electromagnetic radiations. Okay, so the theory is quantum theory for waves. It says that energy is transferring from one place to another as packets of energy. Okay, packets of energy, which are known as quanta or photons. Remember, so that theory is the one being checked in these 2 MCQs. So let's see what are the questions that we have to do. And the first MCQ, of course, it's a very similar one that we did in our theory class. If you recall the question number, as I remember, the question number 2. Okay, it's a very similar one to this one. Okay, so the same theory is applied here. Okay, so let's go to that question. The green light of wavelength 442 nanometer is observed in the emission spectrum of hydrogen. Okay, the energy of 1 photon of green light. So it is given the wavelength lambda 442 nanometers. Okay, so they are asking the energy of 1 photon. Energy of 1 photon. Energy of 1 photon of that particular wavelength. Right, so here's what's going to happen. Electromagnetic radiation is actually known as a flow of packets of energy. Small energy packets are flowing in that. Okay, so the energy of 1 packet, or in other words, we call it as photon, can be found in this form using this formula equal h nu. Nu is the symbol for the frequency, or you can use equal hc over lambda. Okay, so in our question, they haven't given us the frequency, but they have given us is the wavelength. So we have to use that wavelength to find the answer. So the best or the most suitable formula to use is this one, because it contains the wavelength. Okay, if you want to use this one, you have to find first the frequency. Okay, so but it takes some more calculations now. Therefore, strictly straight away using this one is better. Okay, equal hc over lambda. So let's apply it and see what is the energy of 1 photon. Okay, so when we need energy of 1 mole of photon, what we have to do simply, we have to multiply this one by Avogadro constant. Like that's not that difficult, can do. The only thing you have to be careful with you remember what happened to in our theory class discussion, no? We saw several occasions that the students can go wrong, okay, can mix up. So for example, if you don't apply units, then the answers, simplifications may get wrong. Okay, so we'll see. It's MCQ. You have to select the you can select the answer by rounding off the numbers. We'll see. Okay, so in the question, yeah, let's apply the unit sensing, value sensing. Okay, so h is the Planck constant. The value is 6.626 into 10 to the power minus 34 joule seconds. And c is the speed of light, 3 into 10 to the power 8 meters per second. And then you have to divide that one by the lambda, wavelength. So 442 nanometers, which is, if you put it into meters, then you have to convert this units. 442 into 10 to the power minus 9 meters. So let's simplify this one a little bit. You can write it as 4.42 into 10 to the power minus 7 meters. Okay, 4.42 into 10 to the power minus 7 meters. So these all are maths. Okay, here what we are doing is simply we obtaining the data from the question and we just plugging them to our formula. Okay, so you have to see the maths part and chemistry part separately. So focus on how to simplify this one now, right? Okay, so since we can round off the answers, it's better to just lose some decimal values. So you can write it like 6.6, isn't it? You can just omit the 2 6 part and you can bring this 3 here, 6.6 into 3 and division 4.4. Okay, then if you simplify the powers of 10, it is minus 34, 8 and 10 to the power minus 7. Okay, you can simplify these things freely and then this. Now you can see Lamai here it is divisible by 2.2, isn't it? So 4.4 is 2 times 2.2 and 6.6 is 3 times 2.2. So 3 into 3, 9, 9 division 2, it is 4.5 approximately. Okay, so here we did some rounding off. Okay, then if you simplify the powers of 10, if you bring this minus 7 above, it will become minus 15, sorry, plus 15. If you subtract 15 from 34, it is minus 19. So here's the number answer, but don't jump into any conclusions because you can see similar. You can see, I'll show you that one. You can see that my 4.5 into 10 to the power minus 19 answer is there as the first one. Okay, but don't select that one, right? Why? Because if you check the units carefully, it is 10 to the power minus 19 kilojoules. But the answer we are getting here is from joules. You see the difference, right? So now we need to convert that into kilojoules. Okay, see, if you simplify these units, meters to meters, per second to second, they all cancel. So you will get the answer in joules. It's not in kilojoules, right? You have to convert it again. So how do we convert a smaller unit into a bigger unit? How do we convert? So we can convert that one by dividing by 1000. Okay, by dividing from 1000. So it is 4.5 into 10 to the power minus 19. You can divide this one by 10 to the power 3, or you can simply say multiplying by 10 to the power minus 3, isn't it? Then it would become kilojoules. Okay, so your final answer would be 4.5 into 10 to the power minus 22 kilojoules. Right, we did a similar, very close question in our theory class as our, in our question list as our second question. So you can remind that problem and add this one to your paper discussion also. Okay, Lama? Do we have any doubts here? Anything to clarify? I hope now you all got the proper answer. Let's go and see your answers. 16 of you got the correct answer, but still you can see now 3 of you selected the first answer. Okay, so that means you have to apply with proper units. Okay, Lama? Those who got the answer 3, be careful to apply that one, apply units properly. Okay, so check your answer again. It should be kilojoules, not in joules. So majority of you got the proper answer because we did a similar question that day, and I can see now you all have taken that theory point into your minds. Okay, very good. So let's see the second answer before we go to the discussion. Majority of you have selected the answer 3. Good. So let's do a discussion on second one. So if you have taken the other answers, let's say option 1, option 5, if you have any doubts about the method, you can ask. Okay, first we'll go through the question and see how to get that answer. Okay, reaching the excited state by the gaseous ions in the flame test can be represented as M is a metal, so M gas goes to M plus gas. So don't worry about this flame testing and any other thing mentioned here. They'll all be there in your theories in later lessons. Okay, just focus on the quantum wave theory part. Okay, so in the question it says, if the energy change for the above process is 180.66 kilojoules, 180.66 kilojoules, okay, per mole of electrons, what is the wavelength of electromagnetic radiation emitted in the process? Okay, so you can say this energy is emitted as photons. This energy is emitted as photons, right? So then you can apply our formula and find out what is the answer. So what is the formula for this one? Right, so it is about a mole of photons. If it is for one photon, they're asking what? They're asking the wavelength, right? Okay, if it is for one photon, you can use hc over lambda. Hc over lambda. If it is for like two photons, you can multiply this one by 2. But if it is an Avogadro number, what you have to do, you have to multiply this one by Avogadro's constant, right? Which means here. So it will become energy of a mole of photons. So this is the formula we have to apply. They have given the energy of 1 mole of photons. So what we don't know is this wavelength. Okay, is the one we don't know. So let's see how to find it. So first let's subject lambda, and you can write hc into Avogadro's constant over energy. Okay, so let's apply them. 6.626 into 10 to the power minus 34 joule seconds, and 3 into 10 to the power 8 meters per second, and the Avogadro's constant 6.022 into 10 to the power 23 per mole. Then divide by the energy, it is 180.66, and focus on that, it is given in kilojoules. So we can't apply kilo here, so let's convert it into joules and apply joules per mole. So then you can see the units are all cancelling out. Only the meters will remain. See, per mole to per mole, joule to joule, second to per second, they all cancelled. Only meters will remain. So you'll be getting the answer in meters. Okay, right. Now you can simplify the other numbers and powers separately. Okay, look at this for a second. So if you cut this 6.022 with 180.66, you will get 30 here. You'll get 30 here. Okay, and then you can cut that 30 to this 3. Okay, so you'll be getting 6.626 over 10, and these numbers 10 to the power 8, so 10 to the power 34 minus 34, and 10 to the power 8, 10 to the power 23, and down here you have 10 to the power 3. Okay, so I'm going to put this 10 to here, so 10 to the power 4, and here another 4, 27, and 4 and 10 to the power minus 7. So 6.626 into 10 to the power minus 7, the answer will be coming in meters. Okay, but they are expecting our answer in nanometers. So what should I do to convert this one into nanometers? I have to multiply this one by 10 to the power 9, and it will be nanometers. So another 100 will be remaining here. If I put it to this one, 662.6 nanometers will be the answer. Okay, so then you can see our answer 3 is coming. Okay, so yeah, you can't see it here. 662.6 nanometers. Anyway, so I hope you understood the logic. Okay, Lamai, for the first MCQ, what did we do? How did we do the question? We applied equal hc over lambda for one photon. Okay, so it gave the wavelength, and we were asked to find the energy of one photon. So that was no problem, can do that, right? But in the second one, they gave the energy of 1 mole of photon. They asked back what is the wavelength. So you have to come backward and you have to use the other formula, which is expressing the energy of 1 mole of photons. Okay, so two different formulae were there. So now we applied both in order to get some idea. Okay, so let's keep doing this one. In your next paper, which I'm going to give you this week, will also contain another question like this. Okay, right. Let's go to the next question. It is about nuclear balancing. Nuclear balancing. So let's see your answers. I hope now you all are okay with that part. Yeah. Okay. So 13 of you got the proper answer, correct answer. And yeah, some of you have selected answer 3 as well. Yeah, which means you have balanced the first part, but you have missed the second part. That's why you got answer 3. Let's see. Let's see. And importantly, I think those who got answer 3 might have missed this part. Okay, wait, I'll show you it in the question. So did you notice here there are 3 alpha particles are there? 3 alpha particles. Okay, so you might have missed that part. There are 3 alpha particles. You might have forgotten to multiply the proton number and nucleon number by 3. Okay, that's why you have got the answer 3. Understood, Lama? So let's see again. Let's see again how to do that nuclear balancing. Okay, right? So let's see the answer. How to get the answer. And you know this proton number 91. Let's say here A and B. Okay, our theory is 91 should be equal to A plus minus 1. Okay, so the proton number sums should be equal. Isn't it, Lama? Proton number sum should be equal. So our A is going to be 92. Okay, then you can do the same thing for B. 234 is equal to B plus 0. So that means our B is equal to 234. You don't need to write like this. I'm just writing it for explanation. Right? You can just count them and get the answer. So if you remove a beta particle, then your atomic number, the proton number is going to be increased by 1. Remember that one? Beta emission, like that. So X is going to be 92 234. If you check your answers, you can just remove 3 of the options. Answer 1, answer 4, answer 5, they all can be removed. So then your answer will be either 3 or 4. Sorry, 2 or 3. Okay, so to get the correct answer, you have to check this Y also. You have to check this Y also. So if you want, you can write the formula again for just this 91 and 234. So that's the one is balanced now. So if you get this one, then might get confused, right? So let's take Y. Let's put that on as C and D and 3 alpha particles. This part is the important part. That's why I'm separating this also. So here you can say 91 is equal to C plus here 3 into 2, 6. Okay, so 91 is equal to C plus 6. Then C is equal to 85. And then next one, you can talk about D here. 234 is equal to D plus, here also again 3 is affecting. 3 times 4, 12. So D is equal to 234 minus 12, which is 222. Okay, Lama? So then your Y is going to be 85 and 222. So you don't need to look for element. Okay, there's only one answer with the proper combination, which is answer 2. So is that clear to you all, Lama? Are there any doubts? Okay, shall you go to the next one? We have a small problem from chemical calculations. First of all, let's go and see the question. Here's the question. It's about potassium ion concentration. So in this week, we are going to try similar type of questions as the next level of the chemical calculations. So far, we have been completing about balancing and simple mole calculations, stoichiometry, limiting reactants, those things. Okay, we'll be doing more and more questions with this paper class, okay, from those topics. And this week, we are going to discuss about dilution and separation, those two theories I'll be discussing with you. Okay, so this week is also somewhat important, Lamai. So don't miss the classes. Right? We'll see. So question number 4. Let's see your answers real quickly. Yeah, okay, very good. Majority of you got the correct answer, and I can see some other answers as well, but can't find a reason for that. Anyway, we'll see. We'll see. Good, good. Okay, so the question says like this: the concentration of potassium plus ions. Concentration of potassium plus ions, K plus ions. K plus ions. So the concentration of that, this is the symbol for the concentration. We put a square bracket. And in a solution is 0.62 mole per decimeter cube. So that data is given at the end of the line, okay, end of the paragraph. You have to read it properly to understand. Okay, so this is formed by adding several solutions. First of all, a 250 cubic centimeter solution of KCl, 250 cubic centimeter KCl solution of 0.4 m KCl is added, and then again 150 cubic centimeters of 0.2 m K2SO4 is added, and then again another solution of 100 cubic centimeters. We don't know the concentrations. Let's say C mole per decimeter cube. K3PO4 is added. Okay, K3PO4 is added. So I'm writing here capital M, which is indicating it's a symbol for moles per decimeter cube. Okay, so don't use it in when you are answering questions. Okay, let's say you want to write the final answer as concentration, don't write capital M. But when you are doing diagrams and things like that, it is easy to use capital M. Okay, right. And here we are mixing all these things, adding to this one. Okay, then it forms the final solution. So final solution will contain how much volume? 250, 250, yes, 500 cubic centimeters. 500 cubic centimeters. Okay, so they are asking what is this C? Concentration of K3PO4. K3PO4. So it can be done in several ways. But if you check, basically, this KCl is going to give you 1 K plus and Cl minus. This K2SO4 is going to give you 2 K plus. Can you see that now? And in the same way, K3PO4 will give you 3 K plus and PO4 3 minus. So K plus is given by all these three. Okay, all these three. Yeah. Then how do you find this KCl moles? Moles equals concentration into volume, N equals CV. Okay, so if you multiply it, 0.4 mole per decimeter cube multiplied by 0.25 decimeter cube. So I converted the cubic centimeters into decimeters by dividing from 1000. Okay. So like that you can find KCl number of moles. So I'll do it down here so it's more clear to you, because I want to find K2SO4 as well. Okay. Yeah. Let's find out that. Moles of KCl. So we are multiplying 0.4 into by 0.25. Okay. Then I'll be getting 0.0.25 is 1 over 4, 0.1 mole of KCl. Okay. Then moles of K2SO4, 0.2 mole per decimeter cube into 150 cubic centimeters, so 0.15. So I'll be getting 0.03 moles. Then moles of K3PO4, which we don't know. Let's take that concentration as C. So C into 0.1. Okay, moles will be given. So now let's use these numbers. So if you are having 0.1 moles of KCl, I'll be having 0.1 mole of K plus here. So if I am having 0.03 of this one, I'll be having 0.06 of K plus. Understood? So 2 times like that. Here if I am having 0.1 C of potassium phosphate, I'll be having 0.3 C of K plus. So these are the all K plus moles that are available. Okay, and that K plus moles are here. From that we can find out moles of total K plus. Total K plus, you can use that 0.62, that is the concentration, and volume is 500, 0.5 dmq. So 0.31 moles are there. So now what we can do? So total K plus moles is equal to sum of all these three values. 0.1 plus 0.06 plus 0.3 C. From this you can find the value of C. Okay, because this total value is equal to 0.31. Simplify this, then you can find C. Okay, so it is 0.16 plus 0.3 Z equal 0.31. So 0.3 C is equal to divide this, subtract it, it is 0.15. Then if you divide it, you will see, yeah, 0.15 division 0.3, 1.5 division 3, 0.5 moles per decimeter cube. That is the answer. Okay, so majority of you got the answer. That's really good. And I hope this is just one method to do the question, and there can be other methods as well. Okay, so if you did it in a different way and got the same answer, you can show that method in the class, and you can confirm whether you did correct. Okay, understood this, Sandama? Any doubts here? So we'll be doing similar questions and more involving separation and dilution this week also. Okay, this week we are learning the theories properly on this. Okay, right. Let's look at the fifth one. Look at the fifth one. So this is the theory. This is the theory, kind of like the extension of our limiting reactant theories. Okay, which can be specially asked for the gases. Okay, I gave you a theory idea, and we did some questions in the class also. So this is the past paper question I told you about. During the class, I told you we are going to do a past paper question from that theory. Okay, so let's see how many of you got that answer right. Yeah, fifth question. Yeah, most of you got the correct answer. Answer is answer 4. But some of you have taken answer 5 as well. Let's see how answer 4 is coming. Okay. Just look at the question one more time. It is telling H2S gas. H2S gas is reacting with oxygen gas to form H2O and SO2. So first of all, Pute, we have to balance this one. This is not balanced now. We have to balance this. We have to balance it. Okay. And they have given some volumes of each reactant. Okay. So if you balance it using the inspection method, you can see hydrogen is here balanced, sulfur is okay, oxygen is the problem. Oxygen you have 3, but you have 2. So what you're going to do, you put 3 over 2, but you can't keep fractions in balance equations. Therefore, you multiply the whole thing by 2. Okay, then this can be balanced. So your stoichiometry coefficients will be 2 is to 3 is to 2 is 3 is to 2 is 2 is to 3 is to 2 is to 2. These are the coefficients. Okay, these are the coefficients. And then before we go into the question, the answer, let me show you one important part in the question. Did you notice, Lamai? The question is telling that at constant pressure and 250 Celsius. Okay, so this is done at constant pressure and 250 Celsius. Okay, did you notice that? It is telling something very important. If it is done in constant pressure, which means pressure is a constant, you put a square, and here is temperature also the constant value, right? So temperature is also constant. So if you take the PV equal nRT, which is there for the gases, R is anyway a constant. So therefore RT is constant and pressure is constant. You can see volume is proportional to moles. Okay, volume is proportional to moles. This is the theory I discussed that week. Okay, so whatever the thing you do with moles, now you can do with the volume also. Okay, you can do with the volume also. You can see now stoichiometry ratios. Stoichiometry ratio is equal to molar ratio, and then it will be equal to volume ratios as well. Earlier, stoichiometry ratio was only working for moles. But in this situation, this particular situation, if the temperature and pressure are constant, you can say stoichiometry ratio is all same as the volume ratio of the reaction. So now we don't need to find the moles. Okay, we can use the volumes they have given and apply added, reacted, and remaining method, our ARR method for this question. Is that clear, Laman? Then it is telling H2S you have 4 decimeter cube, O2 you have 10 decimeter cube. You don't have anything from these two. Okay, so now just let's see what is the limiting reactant. Okay, so to react 2 of H2S you need 3 of water. Then to react with 4 of this you need how many? 6 of O2, but we have more than that. Understood? So therefore your H2S will fully consume. Okay, and then only 6 of this will be consumed. So if 6 is forming, 4 is reacting here, 4 and 4 should be formed. Understood? This is how you get the reacted number of moles. Here actually it's not moles, Puta, I forgot. It is going with decimeter cube. Decimeter. Instead of moles, we are using what? Volumes. Okay, right, and here it is completely consumed, so it is our limiting reactant, and here only 4 is remaining, 4. So what is the question is asking? It is asking the final volume of the mixture. So final volume is the remaining all gases. You have oxygen remaining, water and SO2 produced. So altogether you have how much volume? 12 decimeter cube. It's a very good question. It's a past paper question, right? So is that okay, Lamai? Any doubts on the question? So I didn't write the statement I'm usually writing because now we have practiced a lot of questions. So it's same like the limiting reactant finding. You are checking how much of each reactant is needed. So for example, if you want to check with oxygen, to react with 10 moles of oxygen, you will need 6.67 moles of 10 division 3 and multiplied by 2 H2S, but we don't have that much of H2S now. So therefore H2S is the limiting reactant. Available H2S will completely consume. Okay. So in the same way, in another question, let's say they gave you volume and temperature constant, volume and temperature constant. Then Puta, according to the same way, if the volume and temperature constant in another question, your pressure will be proportional to moles. Okay, so that means the question, any question you are doing with moles can be done with pressure also. Okay, but remember this scenario goes only with gases. Okay, so remember this question. This is like kind of a good question they gave. Not difficult, but you need to know the method when you are trying that one. So that's the answer for the fifth one. Majority of you did it correct. Very good. Now let's go to the sixth one. There is another limiting reactant question as the number 8. We'll discuss that too in a minute. Okay. So look at this question number 6. During Goldfoil experiment, which was carried out by Rutherford, the reason or reasons for majority of alpha particles penetrating the Goldfoil without any obstacle. It's asking the reason for the penetration. Yeah. Again, majority of you got the answer, but some of you got the answer as 5. I believe those who got the answer 5 might have taken the answer as only D. Right? But lamai, in this question, A, the Goldfoil is being very thin is also a reason. Okay. Otherwise, if it is a thick Goldfoil, then alpha particles will have a difficulty to pass. Understood that? Okay. So the reasons will be Goldfoil being extremely thin and the atom is being at nucleus of the atom is being extremely small. Those are the 2 reasons. Okay, so answer A and D. That's why in Goldfoil experiment, majority of the particles passed without any problem. Okay, and the other 2 statements B and C are wrong. You can say why. Alpha particles have a low penetration ability. So telling it has a high penetration power is wrong. Okay, it is having the lowest penetration power out of alpha, beta, gamma. Okay, you can write something about that. 6th one, B is wrong. Alpha has the lowest penetration power. And look at the next one, why C is wrong. In C, it's telling alpha being positively charged. It's true that alpha is a positively charged one, but it is not the reason. It is not the reason. Okay, so like that you have to give the proper one. So we can say being positively charged does not cause this. So the reasons will be the Goldfoil being extremely thin. So A is correct. So it's very thin. It's 1.5 micrometer thickness. Okay, Goldfoil is very thin. So its thickness is few atomic layers. So that's why the penetrating Goldfoil was very easy. That's one reason. So they expected the majority to penetrate, but interestingly, some of them, few of them did not penetrate due to the nucleus. Okay, so D is also correct. Then you can see according to the Rutherford's planetary model. Okay, so the majority of the space of the atom is empty. Okay, you have only the central positive nucleus, the rest is empty. So the alpha particles that are passing here can freely go without any problem. Only those who are going closer to the nucleus will bend, and those who directly pointed towards nucleus will jump back, bounce back. Okay, like that. Can explain, right? It's not that difficult. So A and D answer 4. A and D answer 4. Right? So there is another ABCD question, question number 7. So I want to see your answers about that one. Yeah, okay, very good. Majority of you got the correct answer. That answer 5. Answer 5 means Lama here all the statements are incorrect. Okay, answer 5 can be given for different options. Let's say you got only one answer correct, then it is answer 5. If nothing is correct like this question, again answer 5. If let's say all are correct, again answer 5. If A, C are correct, again answer 5. Like that, answer 5 can be given for like many occasions. Right here, all the statements are wrong. All the statements are wrong. That's why answer 5 is coming. So we have to write clearly why those statements are wrong. Then our review will be perfect. Okay. So let's take question number 7. A. Why A is wrong? Just tell me, Lama. Let's have answers from you. Can anyone tell me why the first statement is wrong? Short answer you give. It is given some successive ionization energies, and the question is telling that element belongs to the group 3. Good. So we can say regarding the first one, A is wrong. Why? Because it belongs to the element belongs to the X belongs to the second group. Second group. So if you get the ionization energies, to graph them, energy against the electron removed. So 450, 1034, but suddenly it is 9000, like this. So 2 electrons are easily removed. Remember this one we did few weeks ago. Easily removed. So you can say 2 outer electrons. So the group that is having group 2 is the one who having 2 outer electrons. For example, you can say magnesium. Magnesium. O-level configuration is 2, 8, 2. See, 2 outer electrons. Then you can say beryllium, 2, 2. 2 outer electrons, like that. Understood? Then answer B. Why B is wrong? Yes, give me the reason why B is wrong. It says various electromagnetic radiations are different from each other since their speeds are different from each. What do you think? Electromagnetic radiation, are they having different speeds? Yeah, very good. They travel at the same speed. Okay, good. So that's why it is wrong. Okay. You can see electromagnetic waves travels at the same speed. At the same speed in a given medium. In a given medium. Okay. So example, you can say in vacuum, what is the speed? In vacuum, all EM waves 3 into 10 to the power 8 meters per second speed. They all got this speed. Understood? So how do they differ from each other? EM waves are differ from each other. They change from one another because of their wavelength and frequency. See, C equal nu lambda. C equals nu lambda. So if this is constant, then electromagnetic waves are changing from one another because of the wavelength, frequency, and the wavelength. So let's say frequency is higher, wavelength is lower, like that. Okay, so you can write that too. EM waves differ from each other, by frequency and wavelength. Okay, so that's the explanation. Good, good. Yeah, you have given that answer. Same speed, different. Yeah, Shima telling they differ only from wavelengths and frequencies. Good, good. Okay, so like that, practice. What about C? Why C is wrong? It's telling in an electrical field, alpha particles deflect with higher angle relative to beta. Yeah, tell me why alpha particles are having, no, actually alpha particles are having low angles. Angle of beta particles are higher than angle of alpha particle. So why alpha is having a lower angle? Lower angle. Why? What's the reason? Due to alpha is having alpha is bigger than beta. Okay, alpha is having a higher mass. Okay, very good. So alpha is very heavy. Therefore, angle of deflection is low. It's like a huge lorry, right? Trying to take a bend. It's very difficult to take a bend for the lorry, but a motorbike, a smaller one, can take a bend easily, isn't it? Something like that. It's not exactly the same, but you can get the idea. Okay, very good. Right. So due to higher mass. Right. What about D? Why D is wrong? Why D is wrong? D statement is telling Rutherford's Goldfoil experiment revealed that protons, neutrons, but there are protons and neutrons in the nucleus of atom. It's obvious, right? Why it is wrong? Rutherford didn't say anything about the neutron that are there in the nucleus. So an experimentally revealing means giving it evidence. Okay, you can say no evidence about neutron was found by gold foil experiment. That neutron was discovered years later by Chadwick. Okay, so it's a clever question. However, you can see the all statements are incorrect. Okay, like that, give reasons. Okay, you have also suggesting some options. Okay, very good. Yeah, gold foil experiment didn't say anything about neutron. Chadwick discovered the neutron. Like that, you can give answers. Rutherford at some point he told like this, however, okay. He said that something should be there in the nucleus to minimize the repulsion among the protons. He suggested the name neutron, but he couldn't discover or reveal or give evidence for that, okay. So revealing is something like, discovering that meaning. So therefore, the honor of discovery of, neutron goes to Chadwick. So this is the some sample review you can write. You can add again anything you want, no problem. You can just draw Chadwick experiment and can do things like you can draw the angles. You can give a comment about gamma. We didn't discuss about here gamma. Gamma does not deflect in electrical or magnetic field, like that. Just talk about things you already know and write reviews, right? Here when you are writing a review, Lama, it's something like you are teaching to yourself, right? Isn't it? You are looking at the text and you are getting the theory into your head and you are putting into words, in your own words. So that's how that's a very good thing to articulate your knowledge, isn't it? You are learning things, and in exam also you are going to do the same thing, isn't it? You get the answer depending based on the theories, based on the knowledge you are having. Okay, so therefore it's very good practice. So write good reviews, write more, right? Then you can, because in this period you have enough, plenty of time left now, right? Don't have much classes, don't have school, so use that time to do something useful like this. Okay, we'll see. Hmm? For now you all are doing good, so I'm really happy about that. But I want to encourage everyone, so because everyone is not doing this yet, some of them are skipping the paper reviews, but that's not good. So you all have to try, right? So anyway, those who are in here, I believe doing that. So I need to talk this one with those who are not doing this right now. Okay, seventh one we saw, majority of you got the correct answer. Good. So let's go to the eighth one. That is also coming from what? Limiting reactance. That question was a model one. If you remember, a similar question was there in your tute, limiting reactant tute. Okay, we'll see. So majority of you got the correct answer. Good. Some of you have taken answer 5 as well. That means other combination. Yeah, when we are reviewing the question, let's see. Okay. Yeah, and calcium is allowed to react with nitrogen to form the product is not given Puta. That's actually some mistake. You have to be given the products because you don't know this one yet. So the product is anyway Ca3N2 calcium nitride. So you will need 3 calcium. So the stoichiometry ratios will be 3:1:1. Okay, right. And it is telling calcium this much of grams you use like that. First of all, let's apply ARR method and see. Okay. So moles of calcium, you have to divide 180 grams by 40 grams per mole. Okay. So 4.5 moles. Then you can get moles of nitrogen, 49 grams, divided by 28 grams per mole. 28 grams per mole. It's divisible by 7. 7, 4, 3.5, 1.75 grams. Sorry, moles. 1.75 moles. Right. These are the number of moles we added. Okay. So when you are applying ARR method, added reacted remaining calcium 4.5 moles, nitrogen 1.75 moles. We didn't add any of this like this. So what is the number of moles now reacting fully? Or in other words, who's the limiting reactant here? You have to check, no? So remember the sentence we are writing. So to react with 4.5 moles of calcium nitride, let's say the whole 4.5 is reacting. I'll be needing only 1.5 of this one, no? Because 1/3. I divide by 3, 1.5 of this. So I have more than 1.5. So therefore, all this calcium will react. Understood? Here, 1.5 moles of calcium nitride will be formed. Understood that? If you are going in the other way around, to react with this whole thing, you will be needing 3 times of this. Okay, so we write that too. To react with 1.75 mole of N2, we need 1.75 into 3, which is how much? 3.5, 5.25, right? Yes, I remember. Yeah, 1.75 into 3. 5, 1, 21, 22. Yeah, 5.25. We need 5.25 mole of calcium. So we don't have that much, no? We do not have that much. We do not have that much. Therefore, calcium is the limiting reactant. It finishes quickly, finishes fully, completely consumed. Completely consumed. Completely consumed. Therefore, we can say the whole 4.5 will be gone. So nothing will remain here. Here 0.25 moles will be there. Here 1.5 will be gone. So this is the calcium nitride number of moles. Okay. So theoretical mass means what we are expecting here. So you can see this 1.5 is expected. No? So theoretical mass means that one. You can multiply moles of, you can find mass of calcium nitride by multiplying 1.5 moles by its molar mass. So calcium 3, Pa3N2, 120 plus 28, so 148. So what's the value? 148. 148 plus 74 to 1, 222. 222 grams is expected. So now you can say answer A is correct. Then put the B, both N2 and calcium completely consumed is wrong. Only calcium is completely consumed. Only calcium. And what about C? Nitrogen will react completely, that also wrong. Okay, so calcium will react completely. If you go to D now, it's asking the percentage yield. So I think we talk about percentage yield in earlier question, isn't it? Percentage yield. So shall I erase this red color statement? What is percentage yield? So for example, let's say there is a test. Okay, student, there are like 20 MCQs. Student is taking 15 MCQs, right? Okay, so what's the percentage? So you put 15 over 20, right? And then you take 100%. Then you get like 75%. Okay, that's how you get the percentage. Here also you are expecting 222 grams, but you're actually getting, it is mentioned in the question, 1.665 grams. 1.665 grams. Okay, so like that, let's find out the percentage. Think, okay? If you think, will come to you naturally, don't worry. So percentage yield is, you can say actual yield and expected yield into 100%. So actually you got 166.5 grams. You expected 222 grams. You had to put it into 100%. It's not clearly divisible. You have to try a little bit. Okay. Then you will find it is like 75 grams, 75%. Okay, 75%. Or you can just take the long division if you want. If we divide it by 2, 83.25. Okay, divided by 111. 0. You will be having 777. Subtract 5. Yeah, 55. 13. Another 5. Yeah, if you take it like, yeah, 75 is coming. Okay, Lamai. So then you can say D is also correct. A and D are correct. That's why answer 4 came. So those the students who selected like answer, let's say answer 5, no? So see whether why did you go to that one and make the corrections. Okay. Okay. So that's the hard part. Now we have two small questions to discuss. We'll complete that too. And this week's paper, you will be having, structured essay question. That means you have to write the answer. So that's some next level we are going trying to achieve in our, seventh paper. We'll see. If you participate properly through the theory class, and if you only do this paper class with me, then you don't have to worry about a thing. Okay, that's enough. I'm guaranteeing you. But do this one. It's kind of, you have to keep the consistency. You may miss a week, but in the next week you have to cover the earlier week also. Okay? Be consistent. You'll see. Right. What about the question number 9? Let's see your answers. Question number 9. Yeah, okay, very good. Majority of you got the answer for. Very good. When hydrogen gas present in the discharge tube, the EOM ratio for the positive rays is greater than the EOM ratio of the cathode rays. That's wrong. Cathode rays are the one who having highest EOM ratio, and hydrogen has a lower EOM ratio than cathode. But if you consider it among the positive rays, okay, so let's say oxygen's positive rays, nitrogen's positive rays, helium's positive rays, and like that, hydrogen's positive rays will have the highest EOM ratio. Okay, among anode rays, hydrogen has the highest value. Okay, so write that one. You can say in question number 9, first statement is false. You can say why. Among positive rays, hydrogen has the highest value. Right? So that hydrogen's EOM ratio, okay, is 1840 times smaller than the EOM ratio of cathode rays. Because the reason is cathode rays are electrons now. So electrons has a very low mass. Since electron mass is very, very low, therefore its EOM ratio will be really, really high. Okay. So the second statement is telling that proton having a greater mass than electron. That part is true. But anyway, the first statement is wrong. Okay, good. Majority of you have selected the correct answer. Right. Let's see the last one. Photons of 250 nanometers have a higher energy than 460 nanometers. Okay, so 250 nanometer, 460 nanometers. So tell me in which region this 250 is there, Rama. Okay, put the answer. In which region this belongs to. So when wavelength is lower, what will happen? Energy will be higher. In which region this 250 will be there? Yes. Yes, everyone. In which region? It will be there in what? Ultraviolet region. Okay, okay, good. Ultraviolet region. Ultraviolet region. Okay, so high energy. This one is in the visible region. The visible region frequency range, we discussed that last week, is 400 to 700 nanometers. 400 to 700 nanometers. So remember that one. So this is in the red color range. 160. I don't remember the actual color, but however it is in the visible range. That's what we need now. So what do you think? This one is having a high energy. This one is having a low energy. Okay, visible. Can understand, right? Or you can just relate that one with the formula equal h nu or equal hc over lambda. When lambda is higher, energy is lower. Okay, so then first statement is actually correct. Then if you check the second one, it's telling photons of 250 nanometers are not in the visible region. Yeah, telling that is okay, that's correct actually, isn't it? Second statement is also correct because 450, sorry, 250 is in the UV region. But is it the explanation? Is it the explanation? No, it won't be the explanation. It's not the explanation. Look at your answers. Yes. Yeah, majority of you got the correct answer. Good. But 3 of you selected one. Okay. So even though it is not belong to the visible region, we can't be sure whether it will belong to the infrared, isn't it? So the reason is this. It's not in the visible region. Telling that is not enough. We have to tell which region, because except with the visible region, you have many other regions, ultraviolet, infrared, like that. You have to tell what region. Then only we can guess. So anyway, both the statements are correct, but second one can't properly explain the first one. Okay, cannot explain. Just write it down too. Cannot explain the first. Okay, so has to tell how 250 nanometer has high energy. I have to say how, or even from this one, like that. But just simply telling it is not belong to the visible region is not enough. It's not relevant at all. Right? Okay. So any problem? Any problem? Any idea? Any doubt, Lam, you have? So that's how the 10 questions are going. So I'll upload the recording of this also soon. So you can go through one more time and write a good review and bring it to your next theory class. Okay. So see you all in the next class. Next week also you'll do a productive discussion. I'll give you the paper and like I said, there is a structured essay question to write because we are discussing this week hydrogen emission spectrum, which is very, very important. So good night everyone, study well and write a good review.